Good morning, everybody, and a very warm welcome to this Monday morning's webinar, which we, being Alcadon, is hosting together with Sterlite. To start with, I just want to ask, can everybody confirm that they can hear what I'm saying? Perfect. Loud and clear. Today we are going to talk about cable trends in Europe. I'm really pleased to have you on board with us, Kaj.
Thank you.
So thanks for attending. My name is Susanne Stengade. I'm Senior Vice President within the Alcadon Group, responsible for the Western European market. Just super shortly about Alcadon, originally a Swedish-based added value reseller with a strong degree of technical value, working in very close collaboration and partnership together with our customers, but certainly also with our suppliers, partners on the other side. So we deliver not only products, we deliver also solutions, both fiber optic and cover-based, and have done that since 1988. Over the last 5-6 years, Alcadon has been on a journey growing into the European market by acquisitions in mainland Europe, and we have today activities in 8 different countries, in DACH, in Benelux, in UK, Scotland, Ireland, and of course in Scandinavia. We aim to be your preferred supplier of equipment within 4 different segments. It's FTTX, it's data center solutions, it's industry, and it's office or structured cabling. With this, I will pass you the word, Kaj, so a warm welcome.
Thank you, Susanne. And I will talk about cable trends in Europe, what we in STL are experienced when we are out meeting our customers, when we're out in the field meeting the installers. And the topics for today is 2. We will talk about how you are boosting your installation speed, how can you do quicker installations in the field. But I will also talk about fiber densification. How can you optimize your duct space and have as many fibers as ever possible in your existing duct system? So for today, we will talk about STL, very short, brief introduction, who we are. But then we will move over to the more technical, very interesting stuff about IBR technology, our Celesta cable, which is basically an intermittent bonded ribbon fiber. After that, we'll talk about micro high density cables. As I said before, how do you get as much fiber into your existing ducts as ever possible? In the end, there will be questions or answer of questions. So if you have any questions during my presentation, please type them into the chat, and I will do my best to answer that after the presentation. So my name is Kaj Kulstad. I am application engineer or product manager in the optical network business in STL. I've been in this field now for 20 plus years. And one of the things that is repeatedly coming back to me is, how do we save time? How can we do the installation quicker? Because as you all know, time is money. So one of the key things for installation, and that goes from blowing, splicing, total installation, is to do it as fast as ever possible. Second thing the installers or companies are coming to me is that we do have an existing duct base. We do have our ducts in the ground. They are installed. So what can we do to increase the number of fibers in those ducts, or how many fibers can we actually have into those ducts? So let's look at that as well today. But before, let's have a quick, just so that I know who you are. So if you please could answer quickly, what is your industry? Where do you come from? You can do that on your computer. That would be really nice. Perfect, thank you. Perfect. So I can see that we have a little bit of mix. And of course, there is a lot of into the fiber to the home, which is good, but also the industry and office cable. So let's move on and start to look into STL. I mean, STL is a leading optical company working with digital solutions, but we are primarily manufacturing of different components. Even though that we do digital technology solutions, personally, I'm from the optical network group and will focus on that particular topics today. So that will be fiber, cables, but we do have other products as well. So not only fibers, we have connectivity, we have enterprise solutions, and we also have the data center portfolio. But for today, I will talk about cables. I will talk about fibers. That is the key topics. But STL is an Indian company. We do have our fiber manufacturers in India. We do have developing centers, research centers in India. Of course, we have cable factories as well. But we are also having a very strong presence in Europe. We have a big cable factory in Metallogica Bresciana in Italy. And we have a group that is developing and working with optical connectivity products in Milan. So even if STL is based out of India, we have a strong presence and manufacturing sites in Europe. And then we are working all together with the different locations. But let's move on to our Celesta product, which is an intelligent bonded ribbon or intermediate bonded ribbon. Many names have the same name or the same product. Basically, the key for me today is to show how you can actually do the installation 4 times faster by using IBR technology. We know that there is many tests showing that using ribbon splicing, you are doing that more than 4 times faster. But splicing is not, as you all know, the only part of an installation. It's also about preparation, putting the cables into closures, and also do the blowing. So during the talk today, I will show the numbers, how we do this 4 times faster. 4 times faster is not just a number. It's actually converting it. If we look at per million home pass, you are saving 250,000 man hours per million home passed. And that is a cost saving about 12.5 million euro. So that will then equals to 12.5 euro per save per home. So everything adds up. Saving time will also save money, and it helps on manpower during the installations. But let's look at the IBR technology. IBR is basically a ribbon that is bonded together so that you actually can roll the ribbon. You can roll it as a single fiber. So when you look at the cable, this is the cable sample, and you can actually see it more looks like it's a bunch of single fiber units. And that's also why you can handle the ribbon as single fiber, but you do a ribbon splice. So this is actually based on a lot of small ribbon that you can use when you do the ribbon splicing. But when you are tightening all the fibers close together, you're putting them together, you roll them up, and then you put the rolls tied together, so you get a bundle, something like this. That also puts some requirements on the fiber itself. The way to achieve this is to use a bend insensitive fiber that we also call A2 fiber. So using A2 fiber, or a fiber that can bend or is bend insensitive as A2, is the key to get this technology work. Many of our customers are reluctant to A2. A2 fiber has a less mode field diameter. It's around 8.5 microns. And then when they splice it to their legacy network, which may be a D fiber, they then have us to splice that to 9.5 micron. And then we all know that it may be difficult for the OTDR reading. You see gainers, you see step functions. We have tried to solve that. And what we have done is that we introduced what we call the stellar fiber. Stellar fiber is an A2 fiber with a mode field diameter of 9.1. So you can say it's an A2 with a high mode field, or it's a D fiber that you can bend as an A2 fiber. So using stellar fiber and IBR still fits together with your legacy network when you need to splice that together. We have done tests on installation. The cable construction is a little bit different. You don't have a central strength member as in a microcable, but you have a bedded strength member in the jacket of the cable. But that also gives you some very high, good blow performance. So when we did the test, we have done there was a limit or threshold that we need to blow 2 kilometer or 2,000 meter. And we did that in less than 35 minutes on a quite tough track. So the blow performance on this cable works very well. Blow performance is one, but when you do the splicing, you need to make sure that the splicing works. You should do that in the first time. So first time right becomes very important. We have done a lot of different studies into how do you splice IBR to IBR? How do you splice IBR to conventional IBR or IBR to true ribbon? So we have now a significant amount of data. We know that the average splice time is 3 minutes and 6 seconds. So just about 3 minutes for splicing of 12 fibers together. The loss, the average splice loss for this is around 0.03 dB. And when we say 0.3, that is measured on the maximum splice loss in the ribbon. So splice loss is low. First time right works fine. So it becomes easy to handle, and that also adds up to the saving of the time. So when we look at that, you look at the cable preparation, because the structure of the IBR, it's very easy to access the fiber. The preparation goes quickly. So for a 432 fiber cable, per joint, you are spending about 1 hour for the preparations. And then to do the splicing, which is 36 ribbons, you do that in 3 hours. So if you have a system and if we have 2 joints or 2 closures, that will give you a total of 8 hours. When we do the same study with a loose tube cable, the preparation is longer. It takes 3 hours. And then to splice, single fiber splicing, 432 splices, that is roughly 14 hours. So if we add that up and we do 2 joints, 2 closures, we are ending up with spending not 8 hours, we are now spending 34 hours for the preparation. We are also looking at, I mean, that is a more total picture. If you just look at the splicing, if we look at 288 fibers, single fiber splice typically takes 9.7 hours. So that's more than a full day's work. With IBR, you do the splicing in 2.1 hours. So that's 4.5 times faster. Of course, if you are moving up and do bigger cables, the time saving get more. If we take a 1,728 fiber cable, you have 55 hours splicing time if you have to do it every single fiber on each splice. And if you do it with the IBR, you can do that in 9 hours. So it's a long working day to do that, but it is possible. So that is more than 6 times faster. But now this is just for the splicing. If we look at the more bigger picture, we take the installation time, we take the preparation time, we do the calculation for that. That means that you are ending up with 34 versus 8. And that will give you a time saving of 76%. So 4 times faster, which is proven by data, by tests together with our customers. You get also the advantage of having a D fiber that you can actually bend as an A2 fiber. So you are a little bit more 3, if there is any installation that is not perfect, the cable will still work, or the fiber will still work perfectly fine. There is another thing that an IBR is a light cable. It doesn't weigh very much. A lighter cable will save you on transportation. It will save you on handling during the logistic part as well. So I will move on to microcables and start to discuss microcable. If you have had any questions during the IBR, please add that into the chat so we can have a look at that after the presentation. Microcable is cables if you have very limited amount of duct space. Small ducts, small inner diameter. Microcables is construction-wise a very straightforward cable. You have an outer jacket, you have some gel-filled tubes, ripcord to open it up, and then you have a central strength member. It's an old design. It's been on the market for a long time, but still we are moving towards smaller diameter of the cable, and that's the key. You would like to have as much fiber as possible in a cable with very little diameter. So we started with 250 micron fiber, and then you move over to 200 micron fiber, which then was named as the next gen microcable. And now, by optimizing the technology, we now have a high density microcable with an even smaller diameter, still based on 200 micron fibers. I will use the 288 fiber as an example. That cable started out with 250 micron fibers, 9.4 millimeter in diameter. By just moving over to 200 micron fiber, you are now reducing the diameter to 7.9 millimeter. But using this even further with the HD design, you are going down to 7.4 millimeter. And many may think that 7.9, 7.4, both cable will work in a duct with an inner diameter of 10 millimeter, which is true. But going from 7.9 to 7.4 makes a lighter cable and a little bit smaller, and that has a big impact on the blow distance. So if we do look at the blow distance for the 288 fiber cable, the next gen with 7.9 in an IC test track, that blows about 1,000 meter. If we move that and change that to the 7.4 millimeter, we have shown that in the IC test track, you can go up to 1.8 kilometer. So there is a significant longer blow distance for the 288 7.4 millimeter. Because of the little bit less space and the lighter cable, you get more blow distance. So it's not all about duct size or diameter, it's also about the weight of the cable. So we do have that in the majority of fiber counts. We go from 96 fiber up to 164. So 4.6, and then you go up to the 864 in an 11.4 millimeter cable. And of course, that is all done in using the technology with a very thin jacket. You have small tubes. Yes, and I will touch this a little bit later as well. We are using this in the 200 micron fiber design, but the 200 micron fibers are A1, but it all with a mode field diameter of 9.1 in MFD. So if we look at how much fiber do you actually get into these ducts? So we're starting with a duct size of 8 millimeter. The more traditional one, you could have 96 fibers. It's a 6 millimeter cable. If we compare that with the high density, you can actually go up to 192 fiber cables in the same duct size. So there is a lot of gaining to moving over to the high density. I mean, if we look at the 432, you go to that you can have in a 14 mm duct. But then if we look at 12 millimeter duct, you can now have 576 fibers. So there is way to increase the density, increase the number of fibers that you have in your duct with a fiber that is compatible with any D fiber, and even 200 micron fiber is fully compatible with 250 microfibers. And I do get that question a lot from customers and installers or different designers. So if we look at how well do you splice a 200 micron fiber to 250 micron fibers, you have to start to look a little bit about the construction of a fiber. Both fibers have the same glass cladding diameter, which is 125 microns. And because you have the same diameter of the glass itself, it becomes easy to, when you do the splicing, you remove the coating, and yes, you have a thicker coating layer on a 250 micron fiber compared to a 200 micron fiber. But when you remove the coating, you do the splicing, those splice perfectly together. You can see that in this histogram where we have done a number of these kind of splicing. We have an average splice loss of 0.02 dB or 0.022 to be more precise. So splicing wise, you're handling that with the same splice equipment as you are normally using in the installation. So if you have a 250 micron fiber in your network today, moving over to a 200 micron fiber is very easy and straightforward. It doesn't require any new equipment, anything like that. And also because of our A1 fiber has a 9.1 MFD, doing the splicing, doing the OTDR measurement works fine. Sometimes I get a question about what happened in the future. What is the future? What is the next step that is not commonly available today? Well, one thing is, of course, to reduce the diameter of the cable from 200 to 180 micron fiber. If you do that, you need to be aware of that 180 micron fiber will be an A2 fiber, and it will be an A2 fiber with 8.5 microns in mode field diameter. So there are some trade-offs when we are starting to look into the future. If you really would like to do a big step and save space and maximum the number of fibers, of course, you could use the multi-core fiber, which means that in one single fiber, you have 4 different cores. So theoretically, what I'm presenting here can be as 4 times as many fibers. There are field trials that's been done with multi-core fibers, but to be honest, it's further away. You will need a little bit special splice equipment. You will need to handle the 4 cores to go out to single cores. But the technology out there is something that is being investigated. And both 180 multi-core fibers are, of course, very interesting future projects that we will follow. I will just end this. I mean, we're all trying to save the environment. Keep in mind, when you're looking at cable, a cable with less weight requires less material. It's easy for the shipment. So you will always save on the global footprint by using a cable with less weight. So now we are getting into the questions.
Thank you, Kaj. Very interesting. And I can see there are lots of interesting questions. I also have good questions, as always.
Good.
The first one, the benefits of a ribbon cable sounds very good and convincing, but are there any disadvantages? Very nice question, actually.
It is, yes. And disadvantage or advantage, there is a lot of advantage with the IBR. Disadvantage is that, and I don't see that as a disadvantage, but you cannot use a single fiber splice machine. You will need to use a ribbon splice machine to do that. But apart from that, with the IBR, you are handling the cable in the very much same manner as you do when you're used to handle a single fiber cable, like a microcable, loose tube cable. So there are not too many disadvantages in that regard. It's more like you have to be used to do a ribbon splice,
Yeah.
which is a straightforward.
And on the microcable side, if it was microcable to IBR, it would be ribbonized on that side.
Yes.
I guess.
I mean, you're touching a good point. I mean, if you are splicing a ribbon fiber to a single fiber cable, you have two options. You can either ribbonize the single fiber cable so that you can still use the advantage of the time saving of doing a ribbon splice, or you can easily de-ribbonize the IBR cable because it's bonded very lightly. You can peel it off. Maybe and then you can do
it in the sample.
Try to pick it up. I'll try to make a very spontaneous demonstration.
You ruin our sample.
Get you a new one. So this is now the fibers. It can be used, handled as a normal fiber, but this is actually a ribbon. If I would like to de-ribbonize it, you can see the spider web here, or the web. If I would like to de-ribbonize it, I can just pull them apart, and then I can start to do single fiber splicing, if that is what I would like to do. So both options are definitely available.
Interesting, thanks. And I hope that answered that question. Are there any complications in splicing IBR to other cable types?
It's a little bit what we just discussed. It's not really a problem to splicing to other cable types because of either the de-ribbonizing, as I just tried to show on the camera, or the other alternative is that you are ribbonizing the single fiber cable.
Okay.
So the transition is very straightforward to do that.
Thanks. Do you see a potential risk to find qualified manpower to splice on this cable type?
So that is a very hot topic in many of our customers, and that is the same thing goes in whole Europe. You need to have people that can handle the installation. The advantage, if you go to IBR, and since you can do more installation, more splicing per day, you are actually helping. You can use the manpower you have in a more efficient way. I mean, even if they are doing more splices per day, you are not pushing them to work 4 times faster or harder. They are just working more efficient. So training and handling a ribbon splice is straightforward. I got a training and then I had to do a ribbon splice and I succeeded. And I think if I can succeed, anyone can do that. So I would say that it will actually help you on your manpower because you do more faster installation. You are actually saving on man hours you need. I hope that is answering the questions.
The next question in the chat is kind of what we have been through, but would there be any complications in connection with closures and entering the fiber into splice trays?
So this is a very interesting question, and I'm glad I got it. The advantage is when you go into the closure and the entry ports are the same as you're using with single fiber cables. Of course, they had to fit the diameter of the cable, but it's handled in the same way. You're going to the closure. You can even store the fibers in the back if you do a mid-span access. That is handled the same. You are basically routing the fiber into the cassette as you normally do with single fiber cables. The difference is, though, because there is a difference, the cassette itself needs to handle ribbon splice. So for the splice protectors, you have different cassettes. You have cassettes that is for single splice, and then you have cassettes that is for ribbon splices. And that is the only thing you need to change. But the handling, the process is more or less the same.
Thanks. Yes, I'm just being told that it is almost 10:30, and for those of you who has other tasks to do, it's fully okay to exit. You can have the full webinar sent later. However, and then in that case, Kaj and I will thank you for having joined the webinar today. For those of you who like to continue, there are still a lot of questions to be answered, and we will continue for the next 15 minutes.
So thank you for the ones that need to leave us. But yeah, we will stay a little bit longer, have more fun.
The future is actually also a question that I had. Once we start implementing 160 micron fiber, how is that future going to look like as you see it? Is there any risk in the size of the cladding, for instance?
So I discussed the 180 micron fiber, which is a step with a smaller fiber that will give more fibers into the cable. Going from 180 to 160 microfibers is a bigger change. When you have 180 micron fiber, you can still do that with a 125 micron cladding.
Mm-hmm.
But when you go to 160 micron fibers, then we can't just reduce the coating because the coating will be too thin.
Mm-hmm.
So going to 160, you need to reduce the cladding as well. So you have a smaller diameter on the cladding.
Mm-hmm.
And then you need to be a little bit more careful when you're introducing that technology, because then we start to talk about the comparison. How well do you splice the fibers together? As long as you have 160 to 160, perfectly fine. But when you start to do 160 to 200 micron fiber or 250 micron fiber, you have a difference in the core design. And then you need to be careful. How well do you align those fibers together?
Yeah.
So 160 is actually a bigger step in terms of compatibility to your core network.
And it's a bit further away as you see it in cable twins.
It's a bit further away. So I think that we are now in the point where we have the 200 micron fibers, where 200 micron fibers with a mode field diameter that works perfectly well with your existing network. So it's an easy transition for that.
Thanks. That was the question on manpower. How will the future look once we start? That was the 160 micron. Do you see any problems in mismatch on fiber splicing between all of the fibers you've mentioned? Because the stellar fiber is actually a particular Sterlite developed fiber. So A2 stellar towards existing D652D, D657A1.
So mismatch is we're not talking about the mode field diameter, which is something that is seen when you splice the fibers together, and you see that on the OTDR measurements. It's not as much a real loss that you see, but we know that it becomes very difficult to interpret your OTDR reading. And that creates a lot of extra work to approve an OTDR reading. So when we talk about mismatch of that, if you have a legacy network and if you have fiber that is based on D technology with a mode field diameter of 9.1, if you would like to avoid any issues, the best thing to do is to keep having any fiber that has a mode field diameter of 9.1. If that fiber then bends as an A2 or A1 or D, doesn't really matter in that sense. The only thing that matters is how well do you match the mode field diameter. Mm-hmm. So if you have a stellar fiber, which bends as an A2, is classified as an A2, if you splice that to a traditional A2 fiber, you will see a mismatch, because the mode field diameter will then be 8.5 to 9.1.
Yeah.
And then there will be a mismatch. If you have A1, and A1 is 9.1 or can go as 8.8, you are in a better shape. That's better. But A2, when you go down to 8.5, that is where you start to see the potential mismatch in the splicing on the OTDR readings. So if you have a pure A2 network with A2 fiber, of course, there is no mismatch and that works fine. But you have to think twice before you're using it. It will work. A2 to D fiber, you can splice it. The splice loss is not that high. It's actually very little, but it looks big on the OTDR reading. And then the whole explanation on your OTDR measurement starts.
Are you limited actually to the drum size that you can deliver IBR cables, or is that the same as microcables?
You can have different drum size, different cable lengths, depending on your requirement. So when we are producing the cables, we are handling that logistically and operationally like any other cable types that you're used to use.
Okay. It means that potentially you could actually also have engineered length where it's a long stretch of maybe a few hundred kilometers, but the customer would know the distances. That would actually count for IBR cables as well, saying, okay, we would like to have 1,800 meters or 2,500 meters. Would that also be applicable, or it would be more 4, 6, and 8 kilometers?
It would be much more 4, 6, 8 kilometer drums.
Perfect.
That will be the standard, and that is also what we normally deliver to our customer on single fiber cables. So we are not too much into 22. It is possible. We can do it, but it would be an exception. The standard would be to follow the same kind of cable lengths on the drums. Thanks.
Do you both see IBR being used in FTTX, in data centers, industry, whatever?
Yes. So we actually see a lot of IBR connecting data centers. There you go up to the bigger fiber count cables to do the redundancy of the network. You have a lot of fibers between the data centers. And for that, the IBR is a very convenient solution because you can do this splicing so fast, or you are saving time compared to traditional ones. So in data center, yes, we do see that. In fiber to the home, the same things go on there. We actually now have even IBR that is going with 12 fibers and the 48 fibers IBR cables. So small cables. And the whole idea is that you have your IBR backbone network, but even when you go further and closer to your customers, you can still continue to use the advantage with IBR. So yes, we see that in fiber to the home applications as well. Maybe not, of course, the last mile to the home, where you have 1 or 2 fibers into the home, or 4 fibers, depending on where you are in Europe. But the IBR fiber technology is getting closer and closer to the end user.
Do you see actually any markets in Europe where it's really picking up?
So the absolutely biggest part is in UK. So what we see in UK is that they have made a technology shift and using IBR in a lot of the networks today. And when they start using that, when they start to see their own business case on the IBR technology, it looks like they are not going back. Those are also the one that is pushing us to continue, and they have asked us to do this smaller 12 fibers or 24, 48 fibers IBR technology. So it's definitely something that is used, but UK is the front runner in this technology. It seems like a lot of other countries in Europe are following the more traditional way of doing it. So,
but certainly also with the more dense constructions, that's at least what we see from Alcadon side.
Exactly.
Good question coming here in the chat. Why do you think it's not yet so much used in Denmark, for instance?
I think it's based out of tradition. You have a network. You are in your comfort zone when you work with your network. You know that this is working. We have been operating with this for a long time. Going over to IBR and changing over to ribbon splicing is a step that you need to be changing a little bit of your equipment, a little bit of your thinking, and it's always hard to change technology. It's a big first step to do it, and then when you are starting using it, it becomes natural again. But you know what you have, you don't know what you get. I think that's a lot of the explanation why it takes time to change over.
believe with this we are done with the questions in the chat, and
Perfect.
I would like to thank you for getting up really early this morning and joining us in this webinar. It was super interesting, and should there be any more questions coming in, then please give us a call or send us a mail.
Yeah.
So thanks a lot to you, Kaj.
Well, thank you for inviting me and let me talk about this. I mean, I love talking about cables, so I appreciate it very much to be here today.
Yeah.
Thank you so much.